the extrinsic control of our arterial radius. Okay. And I'm going to put in brackets here TPR because that's what this translates to. Right. And so let's start by thinking about our two major control mechanisms, the sympathetic nervous system right, by way of neurons and neurotransmitters. It's our first kind of main mechanism. The second major mechanisms is hormones. Okay, and we'll talk about different examples. Hormones. And this is via the blood, so I'm just going to put blood in this one. Right, hormones via the blood. Okay, so let's start with the sympathetic side. And we've got two kind of large categories. We have norepinephrine. And then we also talked about epinephrine. And epinephrine had a much more kind of complex response. Okay. So norepinephrine, epinephrine. So for epinephrine, we described the alpha adrenergic receptors are pretty much widespread everywhere except the brain, right? In our arterioles everywhere except the brain. So norepinephrine has alpha adrenergic receptors. And this is on most of our arterioles except brain. Okay, except brain. And the result that happens when norepinephrine binds to these alpha adrenergic receptors is vasoconstriction. So this one's pretty straightforward. So vasoconstriction, again, pretty much everywhere. I'm going to put it here again, except brain, right? Everywhere except brain. Alrighty. So that is norepinephrine, one receptor mainly, one response, and then the exception in the brain. Epinephrine, on the other hand, is going to be dose dependent. So let me make a note of that here, and then we'll talk about the two different responses. So epinephrine, we said, is concentration dependent or dose dependent. Alrighty, which means that at low levels, I'm going to put a down arrow here, at low levels, it's going to cause beta 2 receptors to respond, beta 2 receptors. While at high levels, right, it's going to cause both. So at high levels, we're going to see alpha receptors and beta receptors. So I'm going to put it up arrow here as well. So this can be up or down. So low levels, beta 2 only, high levels, both. Okay, that's what these arrows mean. Let's talk about the response that we're going to see at the tissue for each of these. So at high levels with alpha receptors, because these are found widespread, we're going to see a similar mechanism as we did or norepinephrine, which is vasoconstriction everywhere except the brain. Right? Everywhere except brain. On the other hand, beta-2 receptors, we said, are only on two tissues, right? Arterioles to two tissues. So arterioles to our skeletal muscle and arterioles to our heart, right? To cardiac muscle. So the response that that's going to create with beta-2 receptors is vasodilation to those tissues. All right, vasodilation on cardiac muscle and skeletal muscle. Okay, so just to reiterate this, at low concentrations of epinephrine, we have only vasodilation to cardiac and skeletal muscle. At high concentrations of epinephrine, we have both of these responses. Okay, so that's what the concentration dependent means. All right, let's talk about hormones now. And now with hormones, I'm going to put an arrow here to indicate that epinephrine can be a neurotransmitter. It can also be a hormone response, okay? If it's released in the blood from the adrenal medulla, let's make that note here. If it's released from adrenal medulla, it is the hormone form and it will bring about the exact same response, just the source will be different, okay? And then we described two other hormones that had similar effects. One was vasopressin or ADH, right? Vasopressin. ADH or antidiuretic hormone. And that has a similar effect as the other hormone, which is angiotensin 2. Okay. And both of these cause a similar response. Oops, not the prettiest handwriting here. Okay. Both of these cause a similar response, which is vasoconstriction. All right. And that in turn increases TPR, right? Closing those vessels down, making the radius smaller, increasing total peripheral resistance, thereby increasing mean arterial pressure, which is our perfusion pressure. All right. So very important response with these two hormones. Okay. I'm going to pause here for you to digest this for a bit. And if you're finishing up drawing, and then if you have any questions, please let me know. I'm also going to screenshot this. I usually share the drawings with the recording. In case you missed anything, you can always go back as well. Okay. Any questions on the intrinsic mechanisms? We talked about three so far, right? Active hyperemia, increased metabolic demand to the tissue. Reactive hyperemia, an interruption in blood flow that is now being corrected. And then the myogenic response, the stretch on the arteriole results in constriction of the arteriole. Okay, so those are three intrinsic mechanisms. And then we shifted to the extrinsic mechanisms, two major divisions, the sympathetic nervous system via neurons and neurotransmitters that would engage our adrenergic receptors. Alpha adrenergic receptors can bind norepinephrine. And then epinephrine can bind alpha receptors as well as beta-2, mainly beta-2. It has a greater affinity for beta-2. And so at low levels, it will bind beta-2. At high levels, it will bind both. Okay. I'm going to add that here as well, actually. The increased affinity for beta-2. So epinephrine has an increased affinity for beta 2. This is why it binds it even at very low concentrations, but it takes a higher concentration for it to bind the alpha ones. So we're going to see a more pronounced response of both with higher levels.